So this is what we call a transversal puzzle. So when you have more than one transversal line that's intersecting a set of parallel lines, and it creates a puzzle piece that's happening, where I can actually find the measurement of every single one of these angles in this puzzle by only being given 2 angle measurements. Now, instead of finding every single angle, I'm only identifying just a few of them. And they're not in the order. So I actually cannot figure out what angle A is based off of what I'm given. I can't. I have to work through and find things that I do know. But the first thing I want to tell you guys, it's really a good idea if you highlight your parallel lines one color, so that you can see that those are the parallels. And then I would highlight one of your transversals in a color and the other transversal in a different color, so that you can see they're actually very separate from each other. So based off of what I'm seeing here, the very first angle that I'm going to solve for doesn't even have to do with the transversals and parallel lines at all. It actually has to do with the center cluster. And in the center cluster, I can identify the measurement of C, because those 2 transversal lines are actually intersecting each other as well. And when they intersect each other, they form adjacent and vertical angles, don't they? Angles that are next door and angles that are directly opposite to each other or across from each other. So angle C, located right here, is vertical to angle 98 degrees. So I'm going to make a note of that right down here. Angle C is going to be equal to 98 degrees. And I'm going to put in parentheses that it's because of a vertical relationship. The relationship is vertical, and because of that relationship, they are congruent to each other. They are equal to each other. Now, I'm going to focus on using my orange because I'm going to solve everything that is along my orange transversal. So I'm going to do all these little notes, these side notes in orange, because I'm going to solve for the things that are on my orange transversal line. Starting with angle E. Angle E actually is going to have a relationship with angle 38 degrees. In the sense that if I combine those 2 adjacent angles, because they are next door to each other, if I combine those 2 adjacent angles, what relationship do they have, Mylin? Supplementary. So they have a supplementary relationship. They're forming that straight angle here. So angle E is going to be equal to 180 degrees minus the 38, which is equal to 142. So angle E is 142 degrees. And again, I'm going to put in parentheses the reason why I know that. It's because they are supplementary. Here, I'll zoom out a little bit so that you can see a little more. Now, if I follow my transversal down, I'm now going to come to angle B. I can actually solve for angle B because there's a relationship that B has with information up here. B and E are related to each other. What is the relationship that B and E have? Leona? alternate interior. Guys, there's a whole lot of vocabulary for this unit. You have to study that vocabulary on a daily basis, or you're not going to do well when it comes to your test. Okay, so you want to make sure that you're studying that vocabulary. Angle B and angle E are going to have an alternate interior relationship to each other. They're both inside of the parallel lines, and they are on opposite sides and opposite ends of the transversal. Okay, E is on the top right inside, B is on the bottom left inside. So they are equal to each other. Angle B is also going to be 142 degrees. And the reason for that is because it is an alternate interior angle with angle E. It is an alternate interior angle with angle E. Okay, so I'm done solving everything along my orange transversal. I now need to focus on my blue transversal. But there really isn't any information within my blue transversal to help me out with A and D, at least not yet. So there's something that you guys are going to be learning about today, which is the number of degrees inside any given triangle. So up at the very top, I want you to write down all triangles equal 180 degrees. 180 seems to be that magical number. All triangles are 180 degrees. And I technically know two angle measurements inside this triangle that's formed here. I know the measurement for angle C is 98 degrees. I also know the measurement of angle that's opposite of 38, right? It's the direct vertical relationship of 38, which is going to be 38 degrees. So I have a triangle right now, and I'll draw the triangle off to the side, that is 98 degrees and 38 degrees. How do you think we're going to figure out this angle? Allison? Well, right now the angle that's vertical from it is an unknown angle. So how am I going to use what I just found out about triangles, that all triangles are 180, and the fact that I know two angle measurements inside the triangle? Go ahead and try. Very good. So we're going to combine the two angles we know, 98 degrees and 38 degrees, and then we're going to subtract that value from 180. What's left over is our missing angle measurement for here. So if I do 180 minus 98 minus 38, that's going to be equal to 44. So this third angle here, and I'll zoom in so you can see it a little bit better. That third angle inside the triangle is 44. Now that I know that that's 44, do I know what A is? Yeah. I know what A is going to be equal to because A is vertical to that third angle inside the triangle. So that means A is also 44 degrees. A will also be 44 degrees. Sorry, I got to zoom out again. I know it's a lot of zoom in, zoom out, zoom in, zoom out. Okay, so I'm going to write down in blue, because I'm now using my blue transversal, that angle A is equal to 44 degrees because of vertical angles A is 44 degrees because of a vertical angle relationship to an angle you solved for using your Triangle Sum Theorem. And we'll talk about the Triangle Sum Theorem a little bit more in a moment. Okay, now the same thing can be used, again, our same knowledge can be used along this blue transversal. If we look, remember, all of this information can translate down to this information. So that means this angle right here is also 44 degrees. So if I know that this angle is 44 degrees, how do I solve for D? Mylin? Supplementary set. So from here to here, this is also a supplementary set. So angle D is equal to 180 minus the 44. Now I'll zoom in to this bottom information. 180 minus the 44, which is 136 degrees. And again, that's because of the rules that we know, supplementary. Now, there's also a really neat theorem that you technically don't have to know about, but I'm going to share it with you anyway when it comes to these kinds of transversals. So angle A and angle D, they're not alternating because they're both on the same side, right? They're both on the left side of the transversal. So what they're called is same side exterior angles. They're both outside of the parallel lines, but they're on the same side of the transversal. So they're called same side exterior. Okay, we also have what would be called same side interior angles, which would be angles that are inside the parallel lines, but on the same side of the transversal. And I'm going to show you a rule or a neat little tidbit about same side angles. Yes? Yeah, you're going to write about it just right now. Down here at the bottom, just some key reminders about these transversal relationships. Ones that you already know are that alternate exterior, and I'm just going to abbreviate alt ext, alternate exterior. So ALT is alternate, EXT is exterior. Alternate exterior angles are congruent. Alternate exterior are congruent. Alternate interior angles are congruent. These are things we know already. We talked about this on Monday. Corresponding angles are congruent. So we have a lot of angles that are congruent with each other. One that we've been talking about for a week now, vertical angles. Vertical angles are congruent. And then here's what I was mentioning before. The sum of same side interior angles, same side interior, is going to be equal to 180 degrees. When they're on the same side of the transversal, they're both on the left side of the transversal, and they're both in between or inside the parallel lines, that means you'd have one acute and one obtuse angle that will equal 180. It creates a supplementary set. The sum of same side exterior is also equal to 180 degrees. Same side means they're both on the same side of the transversal. They're both on the left, or they're both on the right, but now they're outside the parallel lines. They're on the exterior of the parallel lines. That will equal 180 because one of them's acute and the other's obtuse. Can I intermix angles from one transversal with another transversal? No. Just like I showed you up here. This acute angle along the orange transversal is not the same as the acute angle on the blue transversal. So please be mindful. These rules apply along a single transversal. These rules apply along the single transversal. Okay? Any questions about this? Awesome. Let's go ahead and turn to page 30. We're going to talk about triangles. So with triangles, it's really important that you understand how to name a triangle, how to classify a triangle. So triangles can be classified in two ways. They are classified by their angles. So we have an angles classification. And we also have a sides classification. Right? Triangles are made up of 3 angles and 3 sides. So it only makes sense that you can classify them by their 3 angles and by their 3 sides. So let's start with the angles classification. You have 3 types of angle classifications. You have an acute triangle, and just for all intents and purposes, I'm going to put a triangle instead of writing the word triangle. Saves time. You have an obtuse triangle, and you have a right triangle. So these classifications, if a triangle is called an acute triangle, that means that all the angles, all 3 angles, are acute. And going back to your 6th grade and 5th grade material, acute angles are what? Huh? Acute angles, Omar? An angle that is less than 90 degrees, right? Oh, it's so acute. Okay, it's small. It's less than 90. So put that down in parentheses. Less than 90 degrees. So every one of the angles in an acute triangle is less than 90 degrees. For an obtuse triangle, you have exactly 1 angle that is obtuse. 1 angle that is obtuse. So with an obtuse angle, think obese. What does that mean? Big, right? So what's the definition for an obtuse angle? Abby, you had your hand before. What was it? Greater than 90 degrees, but has to be less than 180. Okay? So it is greater than, I'm going to put a greater than symbol, greater than 90, but less than 180. It is greater than 90, but less than 180. And it can only have one obtuse angle. It cannot have more than one obtuse angle, because remember, I told you before that all triangles equal how many degrees? 180. So if I've got two angles that are larger than 90, I'll have no room for a third angle. It won't be able to create a triangle. So you can only have one angle that is obtuse. The rest of the angles have to be acute. With a right triangle, you have exactly one right angle. One right angle. And a right angle is equal to 90 degrees. Again, you can only have one. If you have more than one right angle, you won't be able to form a triangle. So those are the ways that we classify them by their angles. You also have to know how to classify them by their sides. So we're going to talk about sides classification now. With our sides classification, we have three types. We have scalene, we have isosceles, and we have equilateral. Okay, for a scalene triangle. With a scalene triangle, we're talking about all sides being different. All sides are different measurements. They are different sizes. Now, if all the sides are different, then that actually means all the angles are different as well. Okay, the angles and the sides correlate with each other. Your largest side is directly opposite of your largest angle. Your smallest side is directly opposite of your smallest angle. If all your sides are different measurements, then all your angles have to be different measurements as well. They are correlated. Isosceles. With an isosceles triangle, at least two sides are equal or congruent. At least two sides are equal. That also means two angles would have to be equal. And then speaking of equal, when we're talking about equilateral, all sides are equal. With an equilateral, all sides are equal, which means all angles are equal as well. So let's look at a couple of examples. Based off of the diagram that I'm giving you here, there are two names that we will classify this triangle as, an angle name and a side name. You have to give both, the angle name and the side name. Who can tell me how would we classify this based off of the angles? So think about your angle classification. Is this an acute triangle, an obtuse triangle, or a right triangle? Matthew Johnson? It's a right triangle. Because of the fact that it's got the right angle here, we're going to call it a right triangle. So I can put right, Okay, now let's talk about the sides classification. Who remembers, what did I tell you these lines mean? Elisa. Not parallel, congruent. These lines mean that they are congruent to each other. So is this a scalene, an isosceles, or an equilateral? Omar? Isosceles. So these are the two names for this triangle. It is a right isosceles triangle. Let's do another example. Okay. Given this triangle, let's talk about the angle representation. Brian? Do you see a 90-degree angle? No, it's not a 90-degree angle, so it can't be a right. Philip? Acute. All of these are less than 90 degrees. 60, 31, 89. They're all less than 90 degrees, so all of them are acute. So this is an acute triangle. Okay, the sides. The sides. What would the classification be for the sides? Looking at each of these, what's that going to be? Leona? Scalene. Because they don't have anything in common, right? There's no congruency here, so this would be scalene. Okay, Triangle Sum Theorem. This is what I mentioned to you guys in the previous page, that all triangles equal 180 degrees. That's called Triangle Sum Theorem, where the Triangle Sum Theorem states you have a triangle that has angle X, angle Y, and angle Z, and that if you were to add angle X plus angle Y plus angle Z, it's going to equal 180 degrees. So if they ask you, what is the Triangle Sum Theorem? That's your Triangle Sum Theorem. That X plus Y plus Z is 180. Okay? Or the sum of all three angles is 180. This is useful because just like we were solving for missing angle measurements using angle relationships, you can solve for missing measurements in a triangle using the Triangle Sum Theorem. When you're done, turn to page 31. All right, page 31. So if I have a triangle, we'll do a simple one first. We'll say this is 42 degrees. This is 63 degrees, and this is x degrees, and I want to solve for x. I can use the Triangle Sum Theorem to be able to set up an equation to solve for x. Now, because of the fact that I'm just given two angle measurements that I actually know, it's easy to solve for x. But you want to know how to set up an equation because sometimes it's not as straightforward. So we're going to set it up just to get you prepared for ones that aren't so straightforward. So we've got x plus 42 plus 63. I'm showing that I'm taking all three angles and adding them together, and I'm going to set it equal to 180. And then I'm going to use my knowledge of simplifying before solving. So combining like terms. I can combine that positive 42. Notice I'm going to include the plus sign in front of it. I can include the plus sign so that way I know what type of integer it is. A positive 42 plus 63, and that's going to come out to 105. So by simplifying that, I've got the equation x plus 105 is equal to 180. Then I would just do my inverse operations. Subtract 105 from both sides, and we would get that x is going to be equal to 75 degrees. Now again, this was more of a straightforward one. They're not all like that. Some of them are a little bit more complex. So let's say that this is 2p, this is 3p, and this is 4p. I can't just do 180 minus degrees like I could here. I actually have to set it up as an equation to solve. So again, setting it up as a sum of all three angles, I would take 2p, which is the first angle, add it with 3p, which is that second angle, and then add it with 4p, which is the third angle, and set it equal to 180. So these are all like terms, aren't they? They're all terms of p to the first degree. So I can actually combine these all together. What is 2p plus 3p plus 4p, guys? 9p. So we're going to get 9p is still equal to 180. It's a little simple, Then we would what? Divide by 9. Good. We're going to divide both sides by 9, and we'll get that p is equal to 20. Now, I solved for p, but what if the question was asking me, what are all the angle measurements? Are all of these angle measurements 20? No. My answer is not done. Can I figure out what each of these are? By doing what? By multiplying by 20. It's called substitution. If I substitute what I solved for back into each of these individual expressions, I can figure out each individual angle. So I can do 2 times 20, and that's going to equal 40. So my smallest angle is 40. My middle angle, I would do 3 times 20, and that would equal 60. So my middle angle is 60 degrees. And then for my top, I can do 4 times 20, which is going to equal 80 degrees. And wouldn't you know, if I add 40, 60, and 80 together, what do you think it's going to equal? 180. Okay, let's try another little complex one. So this bottom one is 2x, this one up here is 4x plus 30. So if I wanted to set this up as an equation, I would take each individual angle, all three angles, and write an equation where I'm adding them together to equal 180. So we'll start with the top one. I'm going to write 4x plus 30. That's my first angle. I'm going to add it with my second angle, 2x. And I'm going to add that with my third angle. That doesn't have anything written. But what do I know it is? 90 degrees, because it's got that right angle symbol. That symbol indicates to you that this is 90 degrees. So I'm going to put plus 90, and that's equal to 180 degrees. Again, we got to combine like terms. I've got 4x plus 2x that can be combined together. What is 4x plus 2x? 6x. Then I also have a positive 30 and a positive 90. So I can do 30 plus 90. What is that going to equal? 120. Positive, don't forget to put the plus sign, 120. Okay, and this is all still set equal to 180 degrees. Now I can solve. I would subtract 120 from both sides. That would give me 6x is now equal to 60. And then I would divide both sides by 6. And I would get x is equal to 10. Again, that's what x is equal to. Is that what each angle is? No. I would have to use that value of x to find the measurement of each of the angles. So I could do 2 times 10, which would equal 20 degrees. So this would be a 20 degree angle. And then I could do 4 times 10 plus 30, which would equal 70 degrees. And again, if I take 70, add 20, and add 90, it equals 180. Yes, Eileen? Because I just told you what x equals, right? So instead of 4 times x, I'm going to say 4 times 10. Okay, we have one more quick concept. One more quick concept, and that's the Triangle Inequality Theorem. The Triangle Inequality Theorem. So the Triangle Inequality Theorem basically states that you can tell if 3 sides will form a triangle based off of the sum of the 2 smallest sides. So the sum of the 2 smallest sides, not angles, we're talking about sides. The 2 smallest sides must be greater, not equal to, not less than, it must be greater than the largest side. So if I add the 2 smallest sides together, the 2 smallest numbers together, that sum that I get needs to be bigger than the largest number, than the largest side. So let's take a look at an example. I've got 5 centimeters, 7 centimeters, and 2 centimeters. I want to know, can these 3 numbers or these 3 measurements create a triangle? So the first thing I need to do is identify my 2 smallest sides. What are my 2 smallest numbers up here? 5 and 2. So I'm going to go ahead and circle 5 and 2 in pink. And the sum means I'm going to add them. So I'm going to take 5 and I'm going to add 2, and that's going to equal 7. So now the question is 7 greater than 7? No. 7 is equal to 7. So the sum is equal to the largest. That's not what we want. We want it to be greater than the largest. So will this form a triangle? No. This is not a triangle. This is not going to form a triangle. Let's take a look at another. 12, 5, and 8. 12, 5, and 8. What are my 2 smallest measurements? 5 and 8. So I'm going to circle 5 and 8 in pink. And I'm going to add them. I'm going to take the sum. 5 plus 8 is equal to 13. I need to compare that to 12. How does it compare to 12? It is larger, right? It's greater than 12. So the sum is greater than the largest side. So is it a triangle? Yes. This is a triangle. And that's the triangle inequality theorem. Okay, we have time to be able to do the booklet in class.